So for this one, we have to find the stationary points on the curve f of x equals 2x cubed minus 15x squared plus 24x minus 7 and distinguish between them. So first step is we have to find any stationary points. How do you find stationary points? Derive. And when you derive it, yes, that's right. So basically we derive it and it is a stationary point when f dash x equals 0. Cool? So f of x equals that, so f dash x equals excellent. Okay. Now, this is interesting. Unlike the other ones that we've done, we now have an equation that looks very familiar to us. What sort of equation is it? Cool. So to work out where it equals 0, what do? We want to find its zeros, we want to find its roots. Yeah, let's factorize it. So it's a non-monic, and we know how much we all love non-monics. So I'm going to use the PSF method because I'm still not, I don't use the cross method, I'm sorry. Is that all right? Yeah. Okay. So product, sum, factor. What's the product? Now remember, because it's non-monic, that silence was me unplugging myself, sorry. Yeah, so what we've got to do is we've got to do the 6 times 24, which equals 144. The sum is minus 30. Now, funnily enough, it's actually not too hard to work out which factors you'd use. It's a positive product, so they both have to be negative or positive, correct? But the sum is a negative, which means they both have to be negative, right? So you need two numbers that multiply together to give you 144 and add together to give you minus 30. Now, you're not going to know the factors of 144 off the top of your head, right? But look at the top bit. 6 and 24. And they both have to be negatives. Because you multiply them together, you get a positive. You add those together, you got minus 6 minus 24 gives you minus 30. Cool? Now, this is the step that everyone sort of got a little confused about the other day. When you're doing a monic one and you use this PSF method, you can then just write x minus 6, x minus 24, and you're done. But because it's a non-monic, you can't just do that. What we have to do is we use what we call the split method, and then we factorize by groups, factorize by pairs. Cool? So all we're doing is, see how we've got this minus 30x here? We're going to split that into minus 6 and minus 24x. Is that all right? Okay, just trust me. This minus 6x minus 24x plus 24. Can you guys see that minus 6x minus 24x would give you minus 30x? Okay. Remember when we're using the FOIL method to expand, you do first by first, outer by outer, inner by inner, last by last, and then you collect like terms. So when you first do it, you do first by first, outer by outer, inner by inner, last by last. You end up with how many terms? Before you collect like terms, how many do you end up with? 4. This is that. When you do the first by first, outer by outer, inner by inner, last by last, you end up with 4 terms. And that's what we've just written down in blue. Does that make a bit of sense? Yeah? So it's not like I'm making these numbers up from out of nowhere. It's all based on the factors. So what we do now, and I'll just move down a bit, we pull out a common factor from each pair. Okay, we're going to factorize by pairs. So what's common in 6x squared minus 6x? 6x. Cool. So I'll pull a 6x out the front. And that leaves me with what? X minus 1. Cool. So that's that pair done. Happy with that? So now we've got to pull out something common out of this next pair. Okay, I'm going to pull out 24. What does that leave us? If I pulled out just 24, it would leave me with minus x plus 1, wouldn't it? But remember, what we're trying to do, the aim of doing it this way, is so that these brackets are the same. So if we pull out negative 24, we end up with x minus 1. So if you even think, I want to be left with an x minus 1, what do I have to take out to get to that? Does that make sense? Now you can just write it down. So that would be 6x minus 24, x minus 1. Whew. Everyone happy with that? It probably is. This is the backwards way of doing one of the methods they showed to do expansion, binomial products. Because we just use FOIL, first by first, outer by outer, inner by inner, last by last. Okay? When they were first doing it, the first examples we ever looked at, you actually took this and you split up. And this is why I keep calling it the split method. You split up the first bracket and you went, well, I'm going to do 6x times everything there, which is that. And then I'm going to do minus 24 times everything there, which is that. So that's what they actually showed as the first ever example. And then you can see that this is literally working backwards. You expand it out, then you collect like terms and you're back to there. So it is expansion in absolute reverse. But we normally take quicker steps. But yes, the cross method can be quicker. As long as you remember how to do it. And yeah. All right, so is everyone happy with that? Okay, so this is f-x still, right? We've got f-x. Excellent. Now, we want it to equal 0, correct? So we need to find the roots of this equation. We should remember how to do that. Whoops, wrong way. Okay, so we want what does x equal? For f-x to equal 0, x has to equal what? Start with the second bracket because it's a nice easy one. 1. Not minus 1, 1. Why 1? Why not minus 1? Yeah, because what you're trying to do is get each bracket in turn to equal 0, because 0 times the other bracket will be 0. And that's what we want. So that's 1. Now what's the other one going to have to be? Because someone got this in the assessment, someone got this one wrong, they got it up the wrong way. I'm not sure whether it was you. It might have been. They were sort of flipped. The process was right, but the numbers were flipped. Might not have been your one. I can't remember who it was. I can't remember. But what's the other value going to be? It's not going to be just 24. You need to have 6x has to equal 24. So x has to equal 4. So x equals 4. Now, just to show you what I did there, was I want 6x minus 24 to equal 0. Cool? Because that way that left-hand bracket equals 0. So I just used inverse operation. 6x equals 24, x equals 4. So I added 24 to both sides, then I divided both sides by 6. Okay? The other way you could look at it is that. That's both steps without actually calculating them. I added 24 to both sides and then I divided both sides by 6. Okay? So if you've got a non-monic in one of the brackets, that's basically how you do it. Is that all right? Okay, so now we've got the stationary points. So the stationary, well, I can't spell, stationary when x equals 1 and 4. So now what do we have to do? We found the stationary points. Yeah, because we need to find the nature of those stationary points. So now, where do we sub it into? The original. Cool. So what we're going to do is go f of 1 equals, and what was the original equation? Yes, it was, because that's the 2. Yep. Minus 7. Okay. So you'll notice I've substituted in the 1 because I'm finding f of 1, and I've put everything I've substituted in the brackets to make sure I can see it. So 2 times 1 cubed will be 2, minus 15 times 1 squared will be minus 15, plus 24 times 1, minus 7, minus 13, plus 11. Does everyone else get 4? Yeah? Well, minus 15 plus 24 would be 11, wouldn't it? 11 minus 7. Sorry, minus 13. Just double check. I'm not very awake. 2 minus 15 is minus 13. Plus 24 would be positive 11. Minus 7 would be positive 4. Good. I'm not going completely nuts. Excellent. And before we actually make any statements about anything, I'm actually going to do the next one. So f of 4 equals to 4 cubed minus 15, 4 squared plus 24 times 4 minus 7. Now you can chuck these into calculators. Because I can't do 15 times 16 off the top of my head. I'm lazy. So did anyone get an answer for it? Two times 64 minus 15 times 16 plus 24 times 4 minus 7 gives you... Come on. Minus 23. All right. So we've now got our answers at those particular points. Now, does that help us? Sorry? Baden, what do you reckon? We have found the x value, so we found the stationary point when x equals 1. And then we have subbed it back into the original equation. What have we found? By subbing it into the original equation, what have we found? What's f of x? What's another? We found the y value. So what have we found? We found the coordinates of the stationary point. Awesome. Did the question want us to do that? Cool, we've found them. Right. It didn't actually ask us what the coordinates were. So we found the x value, so we found where it's at, and you were right, we are going to substitute in. What are we going to substitute into? The derivative. Why are we going to substitute into the derivative? What are we trying to find? The nature. Cool. We're trying to find the nature of the stationary points. That's something we'll look at later. Yeah. Yes, you could have. Sorry? Baden was just saying with the non-monic we could have divided everything by 6 to simplify it. Yeah. Okay, so what are we going to do? We have to substitute in, but we've substituted into the original. We're going to substitute into the derivative. Why the derivative? Does anyone remember? Or a point of inflection. Yeah? Yeah. So point of horizontal inflection. A point of horizontal inflection, because we've found where it equals 0. Okay? What we have to do at x. So at this point, at x, it equals 0. So we have to test to the left of it and to the right of it to find out what's happening. Is it increasing as it gets to that point and then decreasing? Increasing and then decreasing, so we're talking about a maximum? Or is it decreasing and then increasing, so we're talking about a minimum? Or is it increasing